I think we'll reserve that for the AD. Yeah, I think so. So I wasn't in Australia, so this is my first time with Gunter as our AD. Everybody knows Gunter, I assume, from other, routing working groups and over the years. Put your hand up in case. There he is. Okay, take over.
Good morning, everyone. Welcome to the LSR session. So now it's 9:30 and let's get started. Our agenda is relatively light this time, so that will allow us some discussion time during the process. But without overdue, let's get started. So I will do the status report first. Okay. So note well, it's Friday, so by now, hope you all seen this. So if not, please read it. And we have one RFC published since last IETF, the OSPF v3 extended LSA advertisement young model. So this one will remove a lot of dependencies we have for other models because they will be augmenting this one. And so we'll be able to progress several of them. And we have two new drafts that move to RFC editor queue during this period. And we have the area proxy that's still there. So we have the two flooding reduction draft that move to editor queue. And we have one draft that's submitted to IESC for publication, and it's gonna be on the telechat on August 8th. Thanks to Tony Lee for writing this. And we make sure the process is written right on paper. And the chairs did accept the challenge raised by some people, and we did it. And we have two drafts adopted. The first one is, of course, already not only adopted, moved to IESC for publication. So the second one was adopted after last IETF. And we have three working group last call. The admin text, Bruno sent us some very good comments, and the authors already have published a new version this week after the window is open, after the data tracker is open. So we want to make sure all the issues are addressed, and then this will be submitted for publication. The multi-TLV, we still have a pending response from the IPR response from the authors, so we cannot close the last call yet. So we'll do that once all authors respond to the last call. And the Flexo, the last one, there are still pending comments to be addressed by the authors.
This week, there's an email thread on that,
Yeah.
so
Yeah,
I expect it next week, Pete.
Yeah, still we are waiting for them to get all the open issues resolved before we move to the next step. So I think this has been going on for a while. So if the authors can just resolve the open issue, that would be
Yeah,
good.
they responded.
Yeah,
It just so
Yeah.
it should be.
And So we have these two drafts in the last call ready state, so in the queue for a while, because this one, the OSPF with SR model, it also includes OSPF v3, so that has dependency on the extended LSA. Now we can progress both of them. And this one is also in the last call queue. So if you want to give a review, this is the time to do it. And we have some other existing young model documents. They will just be further refined and then in the queue for last call. No hurry for them yet. Probably the SRA6 the tool for SRA6 will go first. So for other existing working group document, the distribute, one will be on the agenda. Tony P will do an update, the optimal distributed flooding for dense topologies. And so all others will let them cook. And yeah, so that's pretty much, the last two of them are actually newly adopted. They haven't changed much since the adoption. So hopefully the authors will continue to work on the draft, refine them, solicitate feedbacks, progress them. And then, so we have two drafts. Well, not two. So the PICs actually right now includes 3 documents. We added one more module for the layer 2 member attribute. RFC A667, or I forgot the number, but anyway, so they will do an adoption call for the PICS young model first, and then the authors of the flex algo with link loss also requested adoption call. That's it. That's all I have. Any comments? If not, we'll go to the first presentation.
That's you, Tony. Yeah.
All right, so this is basically an update on this top of flat stuff, which has been adopted, has been around for a while. Largest update, let's run through it. So what's new? We have basically full list of co-authors now. Lots of further discussion, with service provider, other customers. And what came out from discussions with other vendors and customers is that we integrated a new requirement into the draft. So let's roll back. So the previous version of the draft was basically the algorithm without any signaling. Like, switch to a new network, stuff will work. It doesn't need anything centralized. So you don't have any kind of blast radius, which is beyond a single node that you install on the network, maybe recomputation of the tree in most extreme case. Didn't need any configuration, and you can put it into the network node by node, right? So migrate into the network. And implicitly, there were already 2 algorithms in the network, right? Because the standard ISIS does all the flood reduction, namely none, right? Because it floods on all the links. So the new requirement that came out was that people think that it would make sense to have more than one algorithm at the same time on the network. Don't ask about my opinion. And the scenario would be, let's say you deploy the stuff and the stuff has a bug. So you need to roll another algorithm. Or you have two vendors, right? And consequently, what it dragged in was a signaling, because now you have to indicate which algorithm a node runs. That stuff doesn't work. No, doesn't. Well, now it started. Okay. So it helps to understand what's going on if we introduce a simple concept first, which is a well-known graph theory thing, nothing I invented, right? And this thing is called an edge-connected dominating set, or CDS for short. So what this thing basically is a set of edges that touch all the nodes on the network, okay? And any pair of the nodes on the network can have a path, right? And if you see the topology below, it's actually, there's multiple of such things that exist. So the red ones and the blue ones are pretty much, largely disjoint, but all of them have a set of links that touch all the nodes, and all the nodes are connected. And that's basically what the flood reduction algorithm, no matter what it is, builds. Okay. The CDS does not have to be loop-free, right? I was here making for a very nice picture. There is a loop-free variant, but we don't need it. Right. Now, why is that interesting? Because if we start to talk now about mixing algorithm, each algorithm that is introduced, no matter what it is, will be of the CDS in a form or fashion, because otherwise flooding will be broken, okay? So if we are signaling which algorithm runs on the network, we can actually figure out a component, which are all the nodes over which you can build a CDS. So the thing is, like, the nodes that are close enough running an algorithm that you can actually run a flood reduction over them. So we call over such an algorithm. So these components are basically the nodes that run the algorithm. I know there will be a picture later, but bear with me. So, like I said, each algorithm builds a CDS. We call it a star. Don't worry too much about that. And the default ISIS is actually a special case without signaling, and which implies that the flood reduction, the CDS, is basically all the links. Just to give a framework when we start to talk about the stuff later. Okay. So we introduce something we call a pruner, which is like any algorithm that does flood reduction. And what we say is that obviously it forms a CDS, but we put another restriction on it. Wherever it touches a component with another algorithm, it has to flood over this link. All right? Like I said, this is graph theory 100 years. It's people 100 years dead if you want to complain about this stuff. So a pony for a picture, which will become much clearer, right? So what you see here is these components. So the Z we use to denote standard ISIs. And you see that the same algorithm can build multiple components. So the A, those two components are disjoint. I call them not components and not partitions, because partition implies that it's not connected to the rest of the graph. So those are components. That's the correct term. So you have this A prime and the A double prime, and you have three standard islands, right? And you have this B algorithm. And now what you see, then within each component, they will build a CDS, which how they do it is irrelevant. And the pruner restriction means that all the black links have to flood. Now, what does that mean? It basically means that we're building a CDS of all the CDSs. And that proves that the whole graph will be covered by flooding. Okay, in a fully distributed fashion. We can talk about, at the end, I'll talk a little bit about what could be done, but I don't want to do it, and I don't think it's a good idea. Okay. So, and the rest is almost trivial. So there is a TLD with algorithm number, and now nodes can obviously change the algorithm and join another component. And the biggest impact you will see is that you will have two components recompute the CDS, which is like, I think it is necessary and sufficient. You cannot do it more efficiently, okay? And because the Z, so the standard ISIS is a very well-known behavior, a pruner is also allowed to play tricks with the fact that it actually is adjoined to a Z. And I give you an example. So look at the A and the B, A double prime and the B, and the Z triple prime. And you see this triangle. So A and B could figure out, I know that the Z triple prime will always flood through the two links, so I actually don't have to flood on the links from A to B. So those tricks are allowed, right? So in a sense, it's relaxed. You can play tricks with the fact that you know how the normal ISIS works.
But this implies by the dark link that you're not doing that.
No, I just say it's allowed, but the way the pruner is defined is you touch a component with another algorithm, you flood over it. Yeah. That's you know, the normal requirement. But we've seen cases where you can be smart. Do we recommend to be smart? Well, if it works. And that's pretty much all. So now the last trick question is, you go, if you look at this stuff, it's recursive. So you say, funny enough, the black links, the fat links are also CDS. So now we could also prune it. Yes, we could, right? If you look at that precisely. But the problem is that then within a component, you would have to synchronize the edges, right? Imagine the A goes, look, the whole thing is a circle. If I flat to B, the thing will come all the way around. It would. But now the one edge of A has to talk to the other edge of A, and they must run some kind of election saying, no, you flood and I don't. And that will become very heavy, and it can build Hamiltonian cycles. So in clear terms, all of a sudden you may end up flooding all, you know, 3 ways around the diameter before you actually get the flooding done. So that's why it's not a good idea before anybody asks. And that's pretty much all there is to it. So we introduced signaling. I introduced the concept of a pruner, right? So anybody can implement the stuff. There's registry, just the usual, you know, machinations. But that's about it. So that allows to migrate algorithms and change the, you know, the algorithms at any given point in time in and out of the network without any flag days or, you know, configuration or centralized instance or anything like that. Yeah, I'm good. Sorry. Yeah, exactly. What I was looking for. Sorry, I'm sniffling. Thank you.
Les Ginsberg. I have two major comments. The first one is you have two parts to the latest version of the draft. One of them is defining a flooding algorithm, a disk-stop flood as it's been called. And the second is defining a new control mechanism to determine how these flooding algorithms are enabled. These are logically independent. I would really like to see this presented in two separate drafts.
I see zero value in that at this point in time.
So if I have
generating more red tape and delay.
Is there any reason that disk-stop flood couldn't be enabled by a different control mechanism?
And you know, there's nothing preventing a draft saying use this algorithm with this control mechanism and reference this draft.
Okay, I'm just saying architecturally, to me, good software design, et cetera, is these things are logically independent. I should be able to enable any flooding algorithm with any control mechanism, and any control mechanism should support any of the flooding algorithms. So look, to me, this should be presented separately.
My practical customers have zero interest in that. They want an RFC with a distributed plane because of the requirements that I mentioned that we met. Otherwise, there wouldn't be even this draft, correct? And they're perfectly happy with the default algorithm because they don't have to chase 7 drafts and at the end up with 7 vendors having 12 different algorithms that they can actually interoperate all because it's architecturally clean. So frankly, I see no value.
Well, I don't think we know where the marketplace is going to go in terms of a control algorithm. But anyways, you understand my comment. My second comment has to do with the new control algorithm, which, as you've indicated, potentially allows multiple optimized algorithms to be enabled in the network at the same time. Speaking as someone who, like yourself, I'm sure, has had to debug flooding problems in a live network, it's difficult enough with the one algorithm that we have today. We've already made it more difficult by allowing one optimized flooding algorithm to be run in the presence of legacy nodes that are still going to use the standard flooding algorithm.
Mm-hmm.
I do not want to deal with a network that has more than one optimized flooding algorithm. It'll be a nightmare to debug.
And I'm fully there with you, and that's the last thing I advise, but having talked through the stuff with customers, you will end up in this scenario if you find that you deployed something that has a problem and you have to migrate to another algorithm. You'll be in exactly this picture whether you want it or not. So, I don't recommend them like run 4 different, different algorithms and debug them, because it's hell, no discussion. Yeah, it's bad. So I basically tell them, look, here's the default algorithm, that's how the stuff works. It gives you the option in case the stuff doesn't work and somebody comes with some dramatic 5x improvement to roll another algorithm on the network. Will, with extreme likelihood, never happen. And that's also the architectural thing is exercising red tape for me at this point in time.
Well, okay. So just in summary, I have no problem with the flooding algorithm itself. I've supported that in the past. I continue to support it. I find it difficult to support the new control algorithm.
Which is partially based on your comment that the stuff sucks because it doesn't have it. So, it's confusing. Anyway, so no technical comments as far as I see. The stuff is working, okay? That's what we rolling. And so far, I have all the customer requirements fulfilled. It's a difficult technology no matter what. So it's the last thing I recommend before the even least recommended, fast flooding. So normally, architecting network properly and looking what's actually going on and configuring it properly, even at very large scale, there is not really a justification. But the algorithm that is suggested in the draft has a nice property that it can actually look at the graph of a customer and see, by deploying a few nodes, how we could actually reduce the fan out on flooding very significantly in hotspots. So that's roughly where the discussions are going. Build a tooling to analyze the topology, unless it's a fabric, clear, right? But on large networks, you basically go and look for hotspots, and you throw a couple of those nodes that basically start to reduce at the very hotspots. And it normally takes very few nodes. So it's not like you have to roll the whole network onto this stuff. So that's the status of this thing. Thanks.
Yeah. Any other comments? Sort of, I think you two are not really talking to the point. I think less meant, the working group document, since it's already a working group document, and the framework, the control framework you're adding is not within the original scope, and that could be a separate draft.
Where did you do scope? I didn't see in the adoption call a scope. It's completely new concept to me. And if you look at about 100 drafts that had a huge creep on what you call scope, I don't understand how this thing makes any sense or how these procedures are being invented on the fly now. So where was the scope on the adoption call? Because I totally missed it. Don't even know the concept.
Yeah.
I'm still solving the same problem, and I got the new requirement. So what are we playing here? Procedural games?
Hey, let's bring the heat down on this a little bit, Tony.
Right. I'm keeping down already.
I think people have a valid concern that the working group adopted a document and there was significant change to it. So it's worth talking about.
Good. So point me to the concept of a scope and that you cannot add a new requirement to a draft. And I bring you about 50 drafts that pick up new requirements and added things.
Well, are you saying that you should be able to add anything to a draft at all and no one can question it?
No,
Because, okay, then that's what's going on.
no. This thing took a new requirement and it fulfills a requirement. And we can talk about other drafts that were doing the stuff extensively. Just look at something like fast flooding. Okay?
I'm
Which
saying
started
people
basically
people are
define
asking
TCP for ISIS.
people are asking a question, and that's valid.
Good.
You're saying it's not valid to ask. You're very dismissive of it. So let's at least talk it through, right? Let's talk it through.
Good. So I don't see any value except more red tape and possible contention.
But
And
let's see if the
meanwhile, the
working.
stuff will be deploying. So,
Okay, well, let's make sure the working group agrees with you since it's a working group document. That's all.
Sure.
Les Ginsberg again. So I think there's a legitimate process question, but that's not what I'm raising. I think the working group has an interest in that, and that should be resolved. My objection is technical.
Technical?
Yeah.
You
I
didn't
don't-
make a single technical argument. You claim the stuff does not work?
No, I
That's
did.
a technical
I
argument.
did not. So the control algorithm should be able to support any optimized flooding, and any optimized flooding should be able to run under any control algorithm.
And
You may have a preference to put these two things together
no.
for the deployment cases that you're thinking about. But from my point of view, these are logically independent. If I was writing code, I would not embed the control algorithm in the control mechanism in the flooding
Yes.
algorithm and vice versa.
Yes, you wouldn't.
So,
But you're not editing the draft. And if your objection is technical, that you cannot take another control mechanism and reference this algorithm, this is absolutely possible. You just reference this document, says use this algorithm, that's my registry, that's my number. And if you want into this framework inject new algorithms, you just publish an algorithm document and you take a point in the registry. And that will work perfectly fine. I would buy your argument if you say you prevent me from adding algorithms or you prevent me from using this algorithm somewhere else. This is not the case.
Dan Voyer, Canada. Is it possible maybe to write what you have in mind in the list? Because I have a hard time to follow the problem that you're trying. It's already there in the list? Okay. So maybe we can take it from there. Thanks.
Yes, Gunther speaking here as with my routing AD hat on. I just realized I'm sitting at the wrong spot. I'm too far away from the microphones here. So, beginner routing AD, mistake. So I just want to reiterate again what Chris was saying. So actually we are dealing with a working group document. That actually means that, the document is, part of, we form consensus through the working group. It's not really fully in the hands of, the editor of this document.
Fully agree. Yeah.
So, yeah. So yeah. So that is where I think we should be going. So we should form consensus and keep it like that and stay, on the friendly note with everybody.
All right. But my point is that I've never seen a draft where fulfilling a new requirement led to new consensus call. And I would be hard pressed to find an RFC with procedures that actually talks about this kind of stuff.
Hey, Tony, it hasn't happened a lot in our, sorry for breaking the queue. It hasn't happened a lot in our working group, but if you followed IDR, there's been a lot of forced breakup of drafts for different requirements between non-agreeing parties. I mean, we haven't done it a lot. So perhaps we should have, because this has been brought up, perhaps we should just do a consensus call on not the new requirement, but leaving them coupled. I mean, and I agree, they're not necessarily coupled, the control they're two separate things. My personal opinion, speaking as a working group member, is this is much ado about nothing, but.
Yeah,
Yeah.
couldn't agree more.
Yeah, same thing also happened in the PIM working group with like PIM Lite, having, being its own document at this point in time. So.
Tony Lee Juniper, MPLS co-chair. In our working group, if there is a change to the document, we go back to the working group. Even if it's an editorial change, we go back to the working group. Every time.
Yeah, I think the point is there is no problem with a draft taking on new requirements. But if somebody asks, we should take a consensus call on that, I think. Somebody
Yeah,
asks
so-
them to be split up. That's what I'm saying.
Exactly. That's all I was getting at. Was it felt like, Tony, like you were resistant to even questioning the validity of adding new things. I mean, we just have to. The chairs are going to have to make a consensus call on whether the working group is okay with it. That's all. But let's not reject it right out of hand.
Let's do a show of hands. Do you think the control framework should be in a separate draft? No? Yeah, if you haven't logged into the meeting session, please scan the QR code over there so you can do the answer to the show of hands. Ten more seconds. Okay. Go ahead. Yeah. Please go ahead. Yeah.
I understand that, Dan Voyer, Canada. I understand the working group feels, as I watch the poll, towards separate draft, but just be mindful every time we split things in different draft is becoming harder and harder to follow from
Correct.
the receiving end.
Yeah.
And I personally find it messy. So I don't know, unless there is a clear view of that. But again, it's working group. I'm following the beat. I just wanted to be the comment to be heard.
Yeah, and by the way, the show of hands is just giving the chairs a feel for the room, right? This isn't a vote.
Right.
So
yeah.
we'll also take into account what people's actual points are on the mailing list, and then we make a call after that on rough consensus.
This doesn't necessarily mean the result that we will be taking.
So have a split down the middle. All right.
I think it's sort of in the middle. Plus the north.
Good.
Yeah. Okay, so.
AC Lindum, I have one technical question. So for the flooding algorithm, I guess you're using the links, LSPs, to find the 2-hop neighborhoods of everybody.
Yeah.
In ISIS, you advertise the adjacency right away, so there's not any point of missing anybody. Whereas OSPF, you would have to help. You don't advertise the guys that are in exchange but haven't come full yet.
No, you don't. But you have a 3-way. It's not immediate. Almost everybody runs 3-way, right? So there is a couple things exchanged before the adjacency comes up.
But that's soon enough so they don't miss stuff.
Well, we have this PSNP stuff, which seems to work fine. I mean, we implemented the stuff, did a lot of measurements, so the PSNP stuff doesn't seem to kick in much, okay? But I mean, I'll have experience when the stuff rolls on really, really large networks, which obviously takes significant time. So no, we have simulation at large scale, and looks like no, there is no problem there, so you don't need to heal the stuff.
Any other question? If no more question, we'll go to the next presentation.
Still me, right?
Still you.
Okay, so that's a fairly simple idea. We have requirements to start to do fragment timestamping. And what does that mean? So between me and Colby. So we see on large networks, especially with traffic engineering, that the timeliness of information can influence actually the quality of traffic engineering. And we also need a lot of operational tools now at very large scale. So for example, stuff that becomes more and more important is flood delay across the diameter. So max diameter and things like deviation, right? Standard deviation on this kind of stuff. The other thing that hits us is that if you have a very large TED database, some of these parts of the TED database may actually arrive much slower than other parts. And we end up optimizing into parts of the network where the flooding is behind. And algorithms that can actually understand where the parts of the TED is flooding much slower in can do much better job, especially when you start to crank back under congestion. It is also a good measure for the stability of the network, where you see when was the last time any of the nodes updated something, right? Even better measure is how many times it updated it, but that needs more of a tooling. But that gives a very quick look whether your network is basically someone is flapping stuff very quickly, so a reissuing, and a bunch of other things. So now if we want to timestamp the fragments and shuffle the stuff around, we need some kind of clock synchronization, right? There's no way around that, because otherwise things don't mean anything, right? So we don't need to synchronize stratum 0, but we need some kind of a good feeling who has what quality of clock is available on a node that is issuing something like that. So basically, we suggest to carry a funky timestamp, kind of handcrafted to what ISIS practically needs, plus the precision of the clock that is on the node, right? So what is the possible deviation? And yeah, now comes pretty much, the whole thing is a timestamp where we send seconds, and we send a fraction of the second, which is, we try to be really concise. So 4 bits, which gives you a resolution of 60 milliseconds, right? It's like 1/16 of a second. And the precision, which basically tells you the same thing in terms of the clock deviation. So the maximum clock deviation is 1 second we allow. Or if you have something which is all ones, basically means, yeah, this stuff basically doesn't have a particularly good clock. And we use the PTP epoch, which avoids funky things like leap year seconds, the bloody sun not being very precise how Earth turns around it. But it is rolling over like 20, 30 something. So basically what we took is a PTP epoch, and we bit offsetted it, so it starts in 212 or something. And the reason is that if somebody has a really bad implementation, something goes really wrong, you want to realize that stuff doesn't make any sense. He's sending something which was 10 years before. And that gives us an overflow in 2078, where, pretty soon I'll be pushing DASIS. So that puts it out of the scope of my work. That's it. There's some discussions with customers, and some of them want better resolution. I do not think anything beyond 20 millisecond resolution does make any sense. we do not specify what the timestamp means, right? Is it the time the stuff ended up in the flooding queue? Is it the time you generated? Is it the time it has been scheduled for generation? So that already puts it into, you know, a resolution beyond, in my opinion, 50 millisecond as questionable. Otherwise, we wouldn't need LFA, right? But the discussions are ongoing. We can add a bunch of bits and so on. But that's kind of, you know, the idea outlined. That's all.
Hi, Tony Lee. Two comments. First, I understand what you're doing with the timestamp, but from an implementation point of view, I'd really love to see something less funky. Just dropping a Unix timestamp in would make me happier.
We will need fractions anyway. Seconds are not enough. So we end up in fraction, and the Unix timestamp is actually very ill-defined in terms of leap years, leap seconds, stuff like that. That's why PTP guys went to a different epoch.
I was suggesting down to nanoseconds, and yes, I realize it's overkill. But from an implementation point, it's real easy, right? My entire point. Second point, I realize you're doing this for debugging. I get that. It scares me because I'm not sure that there's enough text here to prevent people from doing other things with this. Okay,
No,
and
oh, you mean that it basically makes the network more vulnerable?
No. I'm not worried about vulnerability. I'm thinking somebody's going to come along and write a feature and says that they have to look at timestamp for their feature. I would very, very much appreciate it if you would put another section in here that basically says that doing that would be a really, really bad idea.
I agree. It would be very ill advised.
Okay.
Yes.
So please add more text saying
okay.
that.
Yeah, that's actually a very fair point, that the control plane behavior on the routing protocol should not be affected in any way, but by the values or presence of the stuff. That is very fair. Yeah. Okay, we'll add that. Thanks, Tony. Les
Ginsberg. So to fully appreciate the usefulness of this, and I can see this as potentially useful, you need to clarify that there's a use case directly on the router. Because if you're doing this from a controller, the controller is going to have to retrieve the receive times on each router. So while it's doing that, it could just as easily retrieve the generation. So if you've got a use case on the router itself, this makes some sense to me. But if it's for a controller to use, it does not.
Okay, so I thought you asked for an abstract control plane for it, but fortunately not. But I think you didn't grok it. So yes, the controller can get that stuff, and it's enough the controller hooks up to a single node and get the link state database, because this is on every fragment on the whole network. And the clock is synchronized. So the controller can relate to this clock and understands with what precision this timestamp may deviate from what he has synchronized as time. If you don't have synchronized time on the network, in some reasonable resolution, none of the stuff will work.
No, that's a given. But okay. I'm saying the input you need to whatever use case you have requires not only the timestamp of when the LSP was generated, but the timestamp of when it was received on the various nodes. But you have it on a local router. You also have it on the controller. Yes. No, you don't have it on the controller. Why not? You would have to retrieve it. But my point is, if the controller is going to retrieve the receive time, it could just as easily, as part of that, retrieve the generation time. But if you're on the router itself and you're trying to do something, then clearly you need the generation time to be advertised to know what it is. So I'm just asking, I'm not opposing this. I'm asking you to clarify the use cases. Oh, yeah, so like we talked about it, I went to Colby, added some text, and that's pretty much what it says here. Those are the use cases we have today. So the TED seems very prevalent. Okay. So did you publish a new version already? Sorry? Did you publish a new version already? No, I don't think I published a new version yet. I just added it. Did I? No, I have it in XML. But all right, but if you do, it basically says that, right? Colby said TED, more TED. That's what, that's where we see, especially on crankbacks under heavy load, that we basically go and try to reroute for a part of the network. We're so behind on flooding that we're basically crankbacking like crazy for nothing. All right, I'll look at the updated text. when
You
it's
know, I have
available.
to
Thank you.
I have to push it, but it's really just 2 sentences. I mean, there's no real magic there. But now there is a interesting discussion that also came up with customers having looked at that. A lot of people like to consume BGPLS. And how the hell you stick that into BGPLS is beyond me.
Hi. So maybe to, I think, reiterate what Les was saying, and also I'll echo what Hank said in the chat room. If you have a central controller, you can also be getting timestamps with netconf or one of those protocols. I think that's the point he was saying on if you need this on the router, right? If you're using it on a router, you don't necessarily have the infrastructure for that router to be going out and doing netconf, right? Like you would with a controller.
I'm lost. What does it have to do with netconf at all? Except, yeah, I mean,
if you have
routers.
if you have a centralized controller,
Yeah.
it's talking to all the routers. It can talk to them in lots of different ways, right? It can get the LSP database with timestamps and all that
Yeah.
in ways that don't involve the IGP. But
Right.
if you're needing the timestamp on a router, you don't have that infrastructure. So that was, I think, Les's point about controller versus router use.
So 2 observations. First one, netconf is slow as a pig. I mean, that's a show command, right? Glorified. The second one, so I doubt that will do anything useful. The second one, lots of people with controllers do not attach to every node. They just consume 1 or 2 BGPLS streams or they get the link state database of a node or 2, and that's it. So beats me, I've seen really somebody deploying at scale a controller that talks to every single node in the network.
Okay.
Okay.
I want to echo Tony's point also. I'd be happy with 64 bits and just, like, let's not screw around with weird fractions. Let's just do 64 bits and put nanoseconds in there. They don't have to actually, it doesn't actually have to be, resolved to the nanosecond, but it's just easier.
No, look, I mean, I tried to be clever and save us bytes because, it bites us all the time. It goes on every fragment, right? So, we can do it 64. Take it to the list, go discuss a little bit. Like
Sure.
I said, people discuss whether the resolution 60 milli or something is good enough. Millisecond makes no sense. I mean, you can implement routing protocol at scale that does better than maybe 20 or 30 milliseconds. And also, the interesting discussion is, when is the fragment stamped? Do we have a clear point of implementation? Because between the database generating the stuff and the stuff making it out the box, at scale, there may be seconds. And yeah, normal stuff. And the other problem, because I was thinking like the really useful stuff would be when is it on the interface and being pushed out the box. But we cannot do that because each interface floods independently, right? So we cannot generate different timestamp on each interface, simply not possible. So it has to be something before the stuff hits flooding, but it's not clear to me what it is. So that's the interesting discussion, because people talking millisecond, if we don't standardize that, is an exercise in futility, in my experience. Yeah, all right, so input, take it large. We can do that, costs a couple of bytes. And the other one is the resolution, as I'm discussing with the parties. Okay. And what Tony said, do not use that to optimize ISI's behavior. You'll end up in the valley of tears.
That reminded me, right, because I'm constantly having to tell people who want to synchronize their forwarding database, right, to try to eliminate microloops. That's the obvious one people will immediately go after with this.
So correctly, same thing. Yes. Or they think, that it's extremely smart to actually synchronize the box from the chip all the way to show commands. Yes. And then they're surprised how damn slow the convergence becomes. Yes. Okay.
So my very quick comment, this is Jeff Haas. If you don't like funky formats, we have a nice RFC for that. RFC 8877. It's all in there.
And that's exactly what this thing is referring to. Yeah, and that's why I went to PTP Epoch, which is recommended. And yeah, I had to offset it because to run over. The Unix thing can deliver interesting results, like I said, on leap years and so on, depending on the kernel and so on and so on. So all the high precision guys, nobody's using timestamping.
8777?
8778, it is in the draft. It's actually a very good document by Eastlake and a bunch of guys. Very, very good document recommending how the hell you timestamp, right? Different things. Clever stuff.
David Lamparter, I guess I also need to read that document. I do need to warn that our implementation will get this wrong and in half of the cases put in the Unix timestamp because we don't have the ability to check if the PTP clock is configured correctly.
Oh, you don't need PTP clock for that. Now, where do you pull the stuff from the kernel is, that does
I
not...
need the offset, yes, but I can't guarantee that I know the offset.
No, the offset is fixed. The offset says this is PTP epoch, but shifted by that much. The document says, hey, we just take an offset, so it rolls over much, much later. There's no magic, okay? It's just a constant.
No more question, I guess.
No, it was lively.
Yeah.
Beyond
Thank
what I
you,
believed.
Tony.
Thanks. All right. Sometimes works.
Yeah.
Okay. I just wanted to comment that for especially the first draft, you might want to look in the note-taking to the, what's it called, hedge doc, because I know I didn't get everybody's comments. I know Chris will look in there, but I don't know if the rest of you will. Anyway. Okay, I'm going to give an update on this draft. We had some discussions based on the feedback on the list for the optimized OSPF database exchange. Okay, I'm not going to go through the whole packet sequence again, but basically what happens, let's say router C restarts. It has a database, and it's going to start from the first sequence number, so have the first instance of all its self-originated LSAs. So when it goes during database synchronization with B and E is going to have the stale ones that is more recent. So they're going to request, C is going to request the more recent ones from them, and it will eventually converge. OSPF works as is. I want to point that out. Only the problem is B and E, the way it works today, since they don't need any LSAs from C, C doesn't have any that are more recent. They're going to just go full and advertise the adjacency before C has requested and refreshed or purged the stale LSAs that it had in the previous incantation. Well, previously, we were discovering these stale LSAs during the database exchange. Now, the problem with that, there could be LSAs that C had in a previously, but it doesn't have today, so it won't find these. So the big change that we made is, if you look at the conceptual database exchange in OSPF in RFC 2328, there's a portion of it initially when you go into exchange start, when you'll go through your entire database and build up a database summary. At the same time, you can build up a list of the LSAs in your database that were originated by the restarting router. So what we do is we build them up at the same time we're building the database summary. So it's really not much more overhead. We're just keeping track of all of these. And we're calling this the stale database exchange list. And what we're then doing is, in the current OSPF database exchange state machine, as soon as our link state request list is empty, we'd advertise the adjacency because it would be full with respect to us. But we're not going to do it until not only that list is empty, but this list is empty. And there's two situations under which we will remove LSAs from this list. The first is when the link state database of the restarting neighbor, if it's his database database packets have an instance of the LSA that is the same or more recent, then you remove it, because that means it's not stale, and that'll work. And the other is if you did have a stale version, and then it would go through the whole self-originated LSA where the restarting router will request, in a link state request packet, will request that LSA. The routers, the restarting router's neighbors will send that LSA to that router, and it will either advance the sequence number and update it, or it'll purge it. And in this manner, none of the stale LSAs are missed. And I put in all the places. It looks like it changes a lot, but really a lot of it is just the cleanup for a neighbor that goes down in the state machine. That's repeated all over. It's kind of the phenomenon of, I don't know if you saw Jeff's presentation in IDR. This is just that same type of thing where this is repetition, like that he was talking about, and different ways you can handle it. But so it looks like a lot more. This is just on a smaller scale than the BGP state machine. And well, anyway, we started talking about this. Well, you really don't need to do this for every neighbor. So a couple optimizations we talked about. The first one was keep track of neighbors that you previously had somehow, or keep track of whether or not, well, one way, if you've never had it before, then the list will be empty on the start of it. So that wouldn't matter, because if it weren't active before, you wouldn't have any LSAs in your database. So this one is somewhat interesting, but I think this other one, actually this one's mine, so I think it's a much more it'll save you a lot more. This second optimization is where you don't have to keep track of all the restarting routers stale LSAs. You really only have to keep track of the router and network LSAs that have a link to you. So, well, actually the router LSAs and the network LSAs, you might as well keep track of those. And those are really the only ones you have to make sure that get refreshed or purged prior to advertising that neighbor, because those are the ones that are in your that are in your database, and you'll be able to using them. There's a two-way check in OSPF SPF, so both sides. So as long as you don't advertise the adjacency prior to those that router LSA, that was the one in the original definition of the problem, and any network LSAs where the restarting router was previously the DR and had a link to you. You really have to only do those. Let's see here. Okay, there was a concern on the list that, okay, you're doing this, the restarting, the neighbors of the restarting router are doing this. There could be somewhere in the domain, there could be stale LSAs that are being used. Now, I really don't think this is a problem as long as you do this, because you think about this. In order for this to be a problem, a neighbor of the restarting router has to advertise the adjacency prematurely. So he doesn't do that until, or that router doesn't do that until those stale LSAs have been refreshed or purged. So that's on the same flooding path. So it would be really unlikely that there'd be stale LSAs on the same flooding path as the router that's going to advertise the adjacency to the restarting router. The only way this could happen is if you had LSAs, I mean, LS packets, some LSP packets being dropped and other getting through. Now, how would you handle that? Would you make an arbitrary long delay? In that case, the medicine of not converging for this long time or waiting for retransmission intervals will be much worse. I mean, the medicine would be much more worse than the cure. That's what I'm thinking. And finally, we also talked about this data plane update. Now, my contention is that you know, the synchronization of the state, get rid of the stale LSAs and advertising them before, advertising the adjacency to the restarting router before those are purged. That's a problem of the router that's advertising the adjacency prematurely. The fact that the restarting router hasn't updated the data plane, that's a problem of the restarting router. So I think rather than trying to signal other guys not to advertise their adjacencies, that router can just suppress the advertisement of its adjacency to its neighbors until it's installed the routes to the neighbors. Now, one thing Les pointed out was that you're going to have to be clever about this because the SPF needs the LSP, the LSA, in order to calculate those routes. So you're really going to have to do something to either to put them in your LSA and not advertise it, or do something, or mark them as such that they won't be advertised, or have, you know, there's many ways you can do it, implementation dependent. And I think I covered all the comments that were on the list. That's it.
Yeah, go ahead.
Anchor Chen from Palo Alto Networks. So I have not really followed this this work, but this just reminds me of the issue we had to deal with when we did the BGP press for restart, because remember when the BGP speaker restarts, we are in the receiving mode, right? If you have more than one that are restarting, you have a possibility of deadlock, because we are waiting for the URs. That guy is also waiting for UR. So we have to introduce a bit, say I'm restarting so that the other guy can exclude you and just wait for UR from all the other neighbors instead from you, right? So here, because there could be something similar. I just want to make sure this
You
kind
could,
of
but you
issue
don't need the
taken care of.
You don't need the signaling. I mean, you know, I always feel if you want to get something done, do it yourself.
Because here it seems to me there's something similar in there's a holding pattern initially. Say, okay, I want to wait.
Yeah, we shouldn't be relegated to
right,
the inefficiencies
right.
of other protocols.
Yeah, but just make sure, just make sure this is taken care of. Okay, it works. Yeah. All right. Okay.
Anyway, we can discuss this on the list. I know that BGP has the end of Rev. We've been having a debate on that in another draft I'm in, which some of you are well familiar, the BGP SPF.
So there are two things, right? One is basically whether this router is restarting or not. The other is the end of RIP, right? These two things, they work together. Yeah, in BGP-GR. Yeah.
Leanne, you are the next.
Okay, this is Leanne from China Mobile. Thank you, Estee, for considering the questions we have discussed on the list, and I'm very glad to see it. And I go to two improvements from your slides. The LSA type and the forwarding plane problem. In response to these two, I would like to point out some questions. The first one, Okay, could you please turn to the page 5 or 6? Yeah, or 6. About the optimization. Yeah. I just want to confirm the first one. I'm not very clear about that. Do you mean that this solution does not need to be deployed on all the neighbors of the restarting router?
Yeah, if you weren't previously adjacent to it, you can't have any stale links, even if the router just was adjacent with other routers.
Oh, okay.
I mean, but yeah.
Okay, I got it. But I think in this situation, we must maintain the neighbor list of the previously uh, uh, achieved the full state. So I think in this solution, we have two lists. One is the neighbor list, and the other is the
But
still
this is optional anyway. In thinking about it more, I don't think I would do this if I were to implement.
Yeah. I just confirm it, and I think it will be better. But I also I still think it's a little complex. But also I will leave that to other experts to evaluate the complexity. And the next question about next page about the LSA type. About the reason two. This implies that the still LSA updates or purge have been flooded by the restarting router prior to the router LSA or network LSA continue a link to the restarting router. I think this is a normal situation. And I have just thought about one new scenario. For example, the still LSA is max age, at the max age state, and just as the 23 and 28 RFC described, this LSA will not be added to the database description packet, and it will be added to the retransmit list directly. So I think in this situation, the router LSA containing a link to the neighbor router will arrive, I think, a long time prior to the type 5 LSA.
I'm not sure I keep following it, but it did remind me of one thing I failed to say when I was talking about it. Okay, if you handle if you handle getting rid of the stale LSAs that are in the domain with these links, you will not, the restarting router is going to either update or purge its router LSA and its network LSAs. If it becomes DR again, it'll purge or update the old ones. Now, it won't advertise any adjacencies with anybody else until it has updated or purged all the LSAs that were previously in that guy's database. That's what I'm saying. You really only have to worry about those stale.
I just want to mention that this is the normal flow, and it's not related to the DR or some complex situation. It's just for the P2P. This will happen, and it has described in section 10.3 in RFC 23 and 28. Maybe you can refer to it and think about this situation. What I want to say
Yeah,
is that
can you put that scenario in the list where there'd be a problem with this?
no problem, no problem. I will put this situation in the list.
Okay.
No problem. And what I want
We
to
need
say,
to, Leon,
yeah.
can we move through the queue? We're running out of time. We're out of
Okay.
We're out of
Okay,
time.
thank you. I have another question. Sorry, because I'm focusing on this topic, so I have a lot of queries to to consider. I have the other second one question about the page 7. You have mentioned about the forwarding plan. I think to realize this, we must also control the neighbor state machine of the restarting router. Am I right?
No.
From the
Yeah,
slides,
maybe
I can see that. So I hope this will be clarified on the list or on the draft. Thank you.
OSPF requires both LSAs
Yeah.
to have bidirectional connectivity. So as long as you're not using the stale one, the router that's updating its the restarting router, as long as it delays updating an adjacency until it's installed the routes associated with that adjacency, everything's fine.
Yeah. I think you have missed some special consideration. I will send it to the list. Because
Leanne,
of
can
time
you
limitation,
can you please send your questions to the list? So by now we have already used up all our discussion time. We have 48 minutes, 5 presentation to go. So
Great.
no
management.
Tony, please go ahead. Yeah, please go ahead. No, okay. Let's.
Sorry, very quickly, if you could go back to slide 5. Yeah, so I think this first optimization in AC, I think you're pretty much talked yourself out of it already, but I don't think it applies because the scenarios you're trying to address are not restricted to those cases where the neighbors still haven't timed out their adjacency. Your LSAs, I think, in OSPF by default last for an hour. So it's quite likely that the adjacency has gone down, you don't have any memory of it, but you still want to use these procedures. So I just don't think you don't need this.
Yeah, I tend to agree.
Okay. So please continue the discussion on the list and we'll do the next presentation.
Okay, thank you. This is Leanne, coming from China Mobile. I'm doing the presentation on behalf of all the co-authors.
Can you speak a little bit louder?
Oh, okay. Is this okay now? Okay. It's another solution to solve the same problem as the previous document. This is the first time to present this draft, so I will not detail the problem again. And I just quickly go through the solution about our draft. the key point of the solution is router B. Just as the picture shows, router B supplies advertising the link B to A. All the agency state of B to A until the router B receiving the re-originated LSA from router A. And I think the main point of the two drafts are the similar. So I will focus on the key point difference that can distinguish this proposal from the previous one. The first one is that we're using a signal. We call it the SA indicator to ensure that the suppression is controlled by the restart router. And the second one, we introduce a timer to control the suppress duration, which can reduce the complexity of the solution. Before to illustrate the key difference, I would like to introduce a new use case of the solution. This has been updated in the latest version of the draft. We do not intend initially to resolve this situation, but we found that our solution is more friendly to this situation. And generally speaking, it's the startup procedure. I think the solution can be used to it, not only the restart procedure. I think this can prevent traffic from being directed to the start router too early. Just as the picture shows, during the initial startup, R1 does not want to R5 to direct any traffic to it. Using this signal mechanism, it will be achieved very easily. And this is a little similar to the graceful start in ISIS. But as we all know that in OSPF, we just have the graceful restart, not included the initial start scenario. So we added this use case to the draft. And this slide shows some key points about our solution. I also have sent it to the mailing list, and here we just discuss it further. As we all know that the ideal solution is to find the precise suppress duration, but because of the uncertainty of the flooding and some other reasons, I think the precise time cannot be achieved easily because it must meeting the two conditions. One is it should be received. The COLC refreshing should be received by not only the direct neighbor, but also the remote neighbor. So it's very, very difficult, and I think it's impossible to guide the exact or precise timing for the completion of the old LSC refreshing. So we need to find a compromise solution to balance the effectiveness and the cost of the solution. We introduce a timer here to resolve this problem. And Also, I think this is inspired by some other features such as the stop router timer, LDP sync timer, or some other BGP restart timer. It has several benefits. We have analyzed it. The first one is it's effective for both direct and remote neighbors. And the second one is facilities for floating plane programming. And I think the important thing is this new feature maybe will cause some neighbor state machine deadlock if we change the neighbor machine. I think this is more friendly. And the fourth one, I think the timer is valid for the whole restart router or OSPF process. And the last one, just we have discussed, is no need to distinguish the LSC type of the LSC. Because due to the time limitation, I think I cannot explain it detailedly. You can refer to the slides. And the key point two, we use the exhibit. The fundamental purpose of this point is to ensure that the control end is in the restart router, not the neighbor router. It also are based on the following actors. The first one is it's meeting consistency with other features. And the second one, it can distinguish interface restart and router restart. And the third one, I think this one is very, very important since the unexpected restart can happen at any time. So this feature should be enabled by default. It will be easily realized on the restart router, but the neighbor router cannot achieve this. And the fourth one, we have thought about the multi-neighbors scenario. We just need to deploy it in the restart router. Based on the previous discussion, I just like to summarize the concerns to decide where to control this action, restart router or neighbor router. I strongly suggest that we first determine which side and then consider the cost and effectiveness of the solution. Maybe after that, we can clearly evaluate the pros and cons of each solution. Also, because the time limitation, I will not explain it further. But yeah.
Are there people, does anyone want to comment before we cut the presentation? We can give you 2 more minutes if nobody wants to comment.
Okay, I can finish to write very, very fast. And the next step, we will update the draft according the comments, some from the AC and some other experts. Thank you all very much. And we have requested adoption for one's time. So maybe if no other question, we can request again.
I just have a quick one. I mean, with this is that that OSPF flooding is deterministic, and if it's broken, if it's broken, we wouldn't want the neighbor to come up. You're talking about you could have a deadlock. I don't think I think if you had a deadlock, it would employ a bug. So that's the only thing I would. We can discuss this more on the list, though.
Yes, I think it depends on the developing experience, but as we all know that the OSPF is a very, very complex protocol. The RFC has defined and introduced all kinds of mechanism to resolve this all situation to make sure the neighbor state machine can run normally. I think any change maybe will cause something. It's I think it's a high risk to modify it, and also it's just some experience. I will also leave this to other experts to evaluate.
Tony,
Okay.
you want to say something?
IDBX stuff, so let's get realistic. Conceptually, what is in the draft has been implemented, not necessarily, the way it's described in the draft, has been deployed 10 years at scale. We never saw deadlocks or, any further transients. Enki's comment said is valid for ISIS. That's why we have the hacks like overload timeout, you can say. But because OSPF has basic database synchronization and you have at end of RIP implicit, the concern does not apply.
Okay, thanks. Let's go to the next presentation.
Thank you.
Thanks.
Okay. Hello everyone. I'm Lan Chengqing from Zhongguancun Lab. I'm going to introduce an IGP-based intra-domain self solution. This document is also being discussed in the SAMNet working group. This is the first time I present this document in LSR working group, so I will introduce more about the background and introduce only the highlights of the design. Okay. The SAMNet working group has adopted two drafts about intra-domain source address validation. The first one is intra-domain problem statement. This document summarizes the problems of existing intra-domain self solutions, and the other document is the intra-domain SAMNet architecture. It proposes the architecture which focuses on customer-facing routers, host-facing routers, and AS border routers. And it requires routers to generate self-rules by using self-specific information exchanged among intra-domain routers. And another draft called source prefix advertisement proposes a protocol-independent self-solution under this architecture. So following the above three documents, this document proposes an IGP-based method for intra-domain subnet. It allows routers to communicate self-specific information through IGP. And we define four types of interfaces on which source address validation can be deployed. The first is single home interface. It is the interface of an edge router that faces to a single home subnet, such as interface 3 in this figure. And the second is complete multi-home interface. It means if all routers facing a multi-home subnet are in the local AS, the interfaces facing this subnet are complete multi-home interfaces, such as interface 1 and 2. The third is incomplete multi-home interface. If some routers facing the multi-home subnet are in other ASs, the interfaces facing this subnet are incomplete multi-home interfaces. And the internet interfaces is the interface of an AS border router that faces to another AS. And the goal of intra-domain subnet is to automatically generate prefix allow list or block list on the 4 types of interface. Specifically, for single homing interface, it aims to generate a prefix allow list containing all source prefixes of the facing single homed subnet and only allow data packets from that subnet using source addresses in this allowance.
One quick question: are those subnets, they're in AS1 as well, right? The bottom subnets in the bottom are part of AS1, right?
The subnet in this figure is a host network or custom network of AS1.
Okay.
And for complete multi-home interface, similarly, it also aims to generate an allow list containing all source prefixes of the facing multi-home subnet. But for incomplete multi-home interface, it aims to generate a prefix block list containing source prefixes of intradomain single-homed subnet and intradomain complete multi-homed subnet. It's because in this case, the edge router may not identify all source prefixes of the corresponding subnet without communication between other ASes. And for Ethernet interface, it aims to generate the same prefix block list as on the incomplete multi-homing interfaces. So to achieve these goals, this method has 3 main steps. They are self-specific information generation, self-specific information communication, and self-rule generation. In the first step, edge routers will generate self-specific information containing 4 main types of information. They are source prefix, interface type, subnet tag, and only source flag. The source prefix should contain the source prefix learned through its local routes to the facing subnet. And interface type should be one of the single homing, complete multi-homing, or incomplete multi-homing. And the subnet tag is a unique tag value that identifies the subnet that owns the source prefix. And only source flag is used to indicate whether the source prefix is only used by that subnet. By default, the flag is set, but in some special cases, such as for multi-source prefixes, the flag should be unset. And the interface type and subnet tag value can be configured when the subnet first connects to the edge routers. After that, the edge router can automatically match the interface type and the subnet tag to source prefixes of the corresponding subnet. And as we can see, different from ACL-based self, this solution doesn't need manual configuration when source prefix changes, and only interface type may need to be updated. After that, the edge routers will provide a self-specific information to other routers via IGP. When it distributes IP prefix information of its subnet via IGP, it can carry the other self-specific information with the IP prefix information. And we have 2 approaches to self-specific information communication. The first one is using existing administrative tag sub-TLA, and the second approach is to define a new subnet tag sub-TLA. And if we use the first approach, which can there is a limitation because the administrative tag sub-TLA is not designed for self. So using this tag sub-TLA may conflict with other routing policies. So to avoid possible conflicts, additional operations are needed. And if we choose the second approach, we should define a new subnet tag sub-TLA for ISIs and OSPF, but it can help avoid conflicts and facilitate the operation. And in the following, I will briefly introduce the several generation. For single home interface, it will generate prefix allow list by using its own self-specific information. And for complete multi-home interface, the routers will generate the allow list by using both its own self-specific information and self-specific information from other routers facing the same subnet. And for incomplete multi-home interface and internet interface, the routers can generate a block list by the self-specific information it received from other routers. So in the next step, we'd love to improve the preliminary design of this method. So your comments and suggestions are welcome. Thank you.
Okay, I put 2 minutes on the clock for comments. No, you can, Tony, you can go. There's 2 minutes.
You are in the queue. AC, you are the first.
Okay, I'll be in here. AC Lindum 11. I just wanted to say, are you going to advertise the colors for the interfaces? I know you're gonna advertise a tag on the prefixes, but are you also going to color the interfaces with the same tag? I know we got a color in the like in ISIS and OSPF prefix link extended attributes.
Okay.
It's not called the tag. It's not called the tag for the interface. It's called the color. That's what I'm saying. That's why I said color.
Yeah, thank you. I will correct this.
I think Les, you're in the queue.
Les, yeah.
Right, can be done. What I'm seeing here is that if you have now BGP and IGP, sloshing all this subnet information into the domain, you'll need some kind of a tie breaking, right? And talk about how this thing possibly ends up in BGP, how it's being consumed, because without that, it's just a mechanism, and I don't see how to practically use it. That was my observation when I look what's going on in subnet, right? Somehow, it's like route tie breaking, route types, right? You need some type 5 subnet or something like this, because otherwise none of this stuff makes a lot of sense, because everything will start to install stuff independently and step on top of each other. And you'll face an interesting problem, because the subnet information is actually not particularly precise, especially the farther you get away, right, from the source, that something like BGP can actually try to install something in subnet which will actually suppress the subnet on which you're running and basically bring the distancy down. So somehow it will be interesting framework between preference, what gives you the information, and actually not ended up being, subnetting yourself out of existence while you're consuming it. Thanks.
Thank you for your comments.
Les Ginsburg. There are many things to discuss about subnet. I don't want to do that here. Just a very pointed comment. There's no reason to invent a new tag sub-TLV. We have 32 bits of tags. They're meant to be used for multiple purposes. We don't want to invent a new sub-TLV for every use case of tags. Please don't do that.
Okay.
Okay, thanks. Alvaro, I'm sorry, I locked the queue. We're way out of time.
Okay.
We need to go to the next presentation.
Yeah.
Tony's comment was the picture of the prefix that was coming both in the, I'll just clarify, both via the other AS and via the IGP interface. So Tony was saying that there could be complicated, that was that one picture, the incomplete multi-homed one. That's what he was commenting on.
That's right. Okay, Les Ginsburg, on behalf of my co-authors. So FlexAlgo supports a variety of metric types. Some of them are based on dynamic measurements. And in such cases, you can have asymmetry, meaning that the cost in one direction can be different than the cost in the other direction. When you use this for multicast, this means if you don't take this into account, that the receivers of a multicast stream may send joins in a different direction than the actual stream is going to flow. So here's a quick picture. If you look at the metrics that would be used in a standard IGP SPF, the shortest path would be on the northbound, but when the multicast stream actually gets delivered, it's going to follow the reverse metrics, and it's going to flow on the southbound interface. And so you're going to have a discrepancy between the two, and your RPF checks are going to fail. So what have we proposed? We've proposed a new SPF algorithm to be registered in the registry, which is to use the reverse metric. This will be advertised in the associated FAD, and I've just highlighted that the calculation type is where this field goes. Notice we decided to do this as a new SPF, not a new metric type, because this can be applied to a variety of different metric types. How does this actually get used? As you've seen, the FAD includes the new calculation. The key points are the last two bullets, that the reverse SPF fags in whatever your internal implementation is get installed in a multicast rib, and they're used both for RPF and for PIM signaling. There's a key assumption here that the multicast source as well as the receivers are working on a common data plane, which in this instance really means using a common set of addresses. You get that naturally with FlexAlgo. If you're doing SRv6, we've got algorithm-specific locators. If you're doing IPv4, the easiest way to do this is with IP algo. And that's it. Any questions?
David Lamporter, I believe you're exaggerating a bit on the requirements here. You don't actually need a continuous data plane for the source and destination to support this all the way. It will just work.
I disagree. If you're using an IP address, that's not part of the flex algorithm calculation. You're going to come up with a different path.
Sandy Zhang ZTE. Just I have no comments for the extension itself for now, but I'd like to say we must discuss more details on how to use it for PIM or other multicast technologies. Yeah.
Yeah, and I noticed, I know you have a draft in PIM,
yeah,
which I think is related, and I think that there's some interaction here.
Yeah, we can discuss more about the two drafts.
Yes,
yeah.
Agreed.
Thanks. You are next.
Oh. Yeah. I just had a quick, AC Lindum Liban. I just had a quick question that I know you're doing this, you're signaling this with a calc type. I mean, it seems to make sense. The only thing is, wouldn't you want this for every prefix in the domain as opposed to doing it for specific prefixes and signaling them all with flex algorithm? Like, wouldn't you need like a multicast topology? Wouldn't that be a more common deployment rather than specific prefixes?
So I think there are use cases in which what you say makes sense. And I think in that case, what we've thought about, this is early brainstorming, is that we would invent what I would call a new data plane. And then all of the addresses could participate in that data plane.
But then you wouldn't need to signal a flex algorithm for every prefix.
But you need a way to do the calculation.
Yeah.
Okay. So.
Thanks, Les.
Thank you, Les. Yeah. Thank you for saving us a few minutes. And we'll go to the next one.
Thank you. This is Lian again.
Okay, please go ahead.
Yeah. I'm talking about the IDV extension for optimize the SRv6 seed advertisement. I will go through this slides very quickly. This is the motivation of this draft. As the number of links in the flex algorithms increases, the amount of required LSDBs will increase proportionally. When the LSDB data scale expands, it can overwhelm the system and affect the normal flooding of LSDB, leading to the potential malfunction of the ITP protocol. So the purpose of the solution is very simple, is to reduce the number of the bytes taken by the seed advertising. We conducted analysis for simple scenarios, mainly to clarify the effectiveness of the solution. Just as the picture shows, when there is 100 link and 100 flex algo deployed, the LSP number will reach about 480. And in actual network, many features overlap and various factors affect the flooding. So in the network scope, maybe there we assume that there is 100 routers, and the LSP number will reach about 48,000. Sorry, there is one extra zero. And the main idea is shown as the pictures. We use the bulk alloc method. The main idea is that different FA adopted the same function field, and the seeds of other FAs can be obtained by combining the seed published by FA Bureau with their own FA locator. So what we need to do is just to advertise the exact position of the function field in locator. So this point needs the ITP extension. A new sub TLV is added in the current locator TLV, which is used to declare the position of the function field, which can be inherited by other algorithms. It contains 16 ops state marks. The function field can be obtained by performing a bitwise AND option with the seed. This is the demonstration of the results after deployed this solution. The left is the current advertisement, and the right is the optimized advertisement. And the right font indicates the points of difference between the two. Also, the LSP number comparison is as follows, which can be reduced from 48,000 to about 600. From the comparison, you can see that before the optimization, the number of ISP is a multiple relationship with link and flex algo. And after the optimization, the proportion of LSPs increased by the flex algo has decreased significantly. If a single FA advertises multiple seeds, the effect will be more significant. The new feature can be controlled by a local configuration for network devices that support this feature. And when the network pressure caused by the FA deployment will cause a high network pressure, the switch can be turned on, and otherwise the switch should be turned off. This is a use case to help understanding. First, we obtain the function value by performing a bitwise and operation between the SR value 6 and for flex algo 0 and the ADG state mask. And then obtain the SRV6 and X state by combining the locator value and the function value. The newly added sub-sub TLV in locator TLV replaced the specific NX state for each flex algo. What I want to see here is that the solution is not a perfect one. It requires a certain level of deployment planning. We must assure that the function field of different FA to be the same. But it's a simple and easy way to be deployed. So I think it's just a balance of the complexity and the effectiveness. So, any comments?
I guess I'm up. I'll be first. I heard someplace, I can't remember where, that operators were afraid of complexity. Wouldn't this be complex and prone to error? Also, the compatibility mode, if it's just a switch, it seems like you'd almost need a capability that you advertised around the domain so you could tell if some people didn't support it.
Thank you. About the complexity, I think it's relatively simple method we have found, I think.
Yeah.
And about the capability, I think like other new features, maybe we can add some capability negotiation mechanism, but I think it's not very necessary. Not so special for that.
Peter, please go ahead.
It's Peter Pshenak, Cisco. So I would really like to see a real use case for this, because the fact that you can advertise hundreds of indexes for hundreds of links doesn't mean you want to do it. And I see absolutely no real life example where one would want to do this, because indexes are used for very special purposes like protection and traffic engineering. And typically on a box where you have hundreds of adjacencies, you do not want to do any of this. So before we start to solve the problem, I would really like to see a real use case where this becomes useful. Thank you.
Yes, thank you for your question. Yeah, we have elaborated the use case in the draft. Maybe you can refer to if anything, any comments we can improve it. And it's just one
The
scenario.
use case in the draft is not specified. What you have in the draft is not sufficient to convince me that there is a need to solve this.
Okay, I will check it. I thought that we have updated this to the draft. If not, we will update.
In the interest of time, please continue the discussion on the list, and we'll go to the last presentation.
Hi, this is Tang Waling from New to H3C. It's about ITP car word shortcut. So background, this draft aim to add color to ITP routers and enable the selection of SR policy based on color during ITP shortcut calculation. Let's take a look at two use cases. First, the use case is about the SR policy based ITP car word routing. For control planes, BGP advertiser route between E1 and E2 will next hop as E2 and color as color 1. within these three OSP areas, ITP shortcut calculation are performed and direct traffic to the corresponding SR policy based on the color. In OSP area on device E1, perform the ITP shortcut calculation. And outer calculation select the outgoing interface of the router with destination address of E2 and the color 1 to the SR policy 1 with the color 1. BGP service router are relied through ITP car wide router based on color and next hop. Another use case is about the SRv6 locator based on ITP car router. In OSPF area 1 on the device E1 perform the ITP shortcut calculation and alter the calculation selecting the outgoing or interface of the locator E2 and the color 1 to the SR policy 1 with the color 1. The BP service route are related to the SRv6 locator router. For the forwarding place, the traffic in each area follows the corresponding colors SR policy and thus reaching the E2 device. The proposed solution outlined in this document is to utilize the colored IP prefix and steer the colored prefix over color matched tunnel. This is about how to advertise the color for ISP prefix. The first approach is by using existing administrator tag. Another approach is defining a new color sub-TLA. From the perspective of simplified protocols, tag could be used for mapping colors. However, it requires the tag to color mapping configuration to be consistent across the entire network. We update the SPF computation of IGP shortcut as described in RFC 1396. Add the following step when calculating next hop for prefix advertised by a node. If a prefix is colored, we look up the first hop information of the advertised node for T tunnels with the same color. If they are eligible T tunnels, we compare the cost of pass over those T tunnels and use next hop of T tunnels with the lowest pass cost. If there is no eligible T tunnels, we use native agency next hop. If a prefix has no color, we use the next hop with the lowest pass cost. After last ITO meeting, we updated by using tag for color mapping. And we also add use case for SRMPLs and SRv6. That's all. Thank you. Any question, comment, are welcome.
Peter, please go ahead.
So Peter Chenak from Cisco. I don't see anything that needs to be standardized here. This is about tunnel head behavior, picking up the tunnel based on some local configuration or based on some tags which is associated with the prefix. There are implementations that are doing this for many years already. There is absolutely nothing to be standardized here.
Thank you. We need to update RFC 1396 to handle to mapping colors to the T tunnels during IGP shortcut calculation.
I don't agree, but let's keep it to the working group.
Yeah, thanks.
Actually, I was going to say what Peter said, that the shortcut behavior is purely local and based on the local coloring of the tunnel endpoint there. But Peter said the same thing. So
we has the real use case in SRv6 like this use case.
Bia, you want to say something quick?
Yeah, I just want to express that whatever the solution, the current RFC cannot meet this scenario. So I think this is a new scenario and we should resolve it. And also, just like Peter said, we also hope to hear the opinions of the working group on whether the existing document needs to be updated or controlled through local configuration. But which one we choose, whatever we choose, I think that we need one solution to resolve this problem. Thank you.
With that, I think we are running out of time. Please continue the discussion on the list. Thank you to everyone for attending this session and the good discussions. We'll see you in Dublin.
6.
at the Templar Bar.
Yeah, apparently we need to leave more than 30 minutes of free time.
Yeah, we had 30 minutes and we used them for good discussions.
Yep. Thanks, everybody.
Can you just go back up once? Go up, yeah, go up one slide. I just wanted to. Oh, that's all right. I mean,
oh, I think he.